change of audio and video again because I'm using a different device again, and we can see how it goes. You can tell me what you think of it. So I'm looking at some solar lights, and these came from a UK supermarket called Tesco because summer is approaching, the solar light season is approaching, and they had the option of the luxurious £5.25 for five chromium, well, stainless steel solar lights with colour changing LEDs. That means it's probably, as opposed to this version, it's probably got the little extra capacitor and diode, which is good, it's more versatile. But £4.20 for the non-luxurious, just standard black plastic ones. So let's cut these open and we'll take one of them apart. We'll whip the circuit boards out of them and we can take a wee look at what's inside. So I shall just chop through the plastic here and liberate one of the lights and put the other ones out of the way. I'll get one of the stainless steel ones out in a reckless manner, completely destroying it in the process. Okay, here are our donor lights. I can already see them glowing because the battery has got a little pull tab and there's enough light hitting it from the bench lights to actually make the LEDs glow in that. I don't know if you're going to see that though. Oh, you can see the little red glow in there. Not much in this one though, although if I hold it up to the light, it does start glowing boring cold white. So here's the little tab. Then we can see it. Oh, it's not actually lighting. Is that just made a bad connection inside? It's lost points already. It is now working. And this one, and these are the only bits we need. I'll put these out the way as well. Oh, it's got instructions. That's handy. Let's just get rid of them. And I'll pull the tab out of this one. That one does work straight away. Excellent. Right. Let's open these up. And that's the first thing I'm seeing here is that it's not overly obvious how they open. I think these may actually spudge apart. Is this going to make horrible loud noises? Oh, it has got a little clip here to open it. It has got a very, I was expecting it to have a bigger cell, but it's only got one of the little tiny cells here with the spring metal tab against it. That could explain why it wasn't making that great a connection. They've used one of the tiny, let me zoom down in this with super zoom here, and we can focus onto that. That's quite tacky. But there, oh blimey, it's a little surface mount chip as well on the back. Okay, let's see what the other one's like. Is it going to be the same? I had this hope that it was going to be one of the little fractional size AAA type cells. But what do you expect for £1? What have we got? We've got the same arrangement. They've got the same little spring-loaded contact against the ordinary sort of button cell. Okay. Right, tell you what, I can see, and the surface mount components are for the capacitor and diode. Okay, tell you what, I'll take a close-up picture of these so we can take a look at it, and I'll show you the difference between the two of them and how these make excellent little donor modules for repairing existing solar lights. Okay, so I shall take a picture of this and we'll take a closer look. One moment, please. Reverse engineering is complete. Let's explore, and I'll zoom down just a little tiny bit here just to get down onto the circuit board. So no great surprises. The circuit board, because it was really zoomed in, it was a bit sort of grainy, so I've sharpened it up with a pen, just the outline, so you can see the layout of the tracks. We've got this very large common positive bus, and this is this bizarre. I mean, take a look at this. Let me just focus onto this and zoom up. That contact there is going to be the biggest weakness, isn't it? So if you have some of these and you have intermittency problems, it might be worth just hinging this back, put a dab of Vaseline on it, and then just clamp that together tightly with a cable tie. It's just options, but let's get back down to the thing in question, which is this now completely out of focus. Now it's in focus. Circuit board. We've got this rather spectacularly shaped negative connection for the battery connection, and then it goes round to these. There are 3 pads here. One is for the solar negative, one is not used, and one is for the LED. We've got the solar positive comes in here, ducks under this little chip. It's marked F52, ZV by the look of it. It's the classic YX8018 chip, but in a different disguise, maybe a different manufacturer. And because this is a colour changing LED, we've got the extra components. We've actually got a Schottky diode here. You can use a 1N4148 and place that, and then a little capacitor. And then the inductor on the other side, which is 120 microhenry, which is a sort of compromise between intensity and sort of runtime on such a small lithium cell. Would have been nicer if it had been a bigger lithium nickel metal hydride cell. So let me show you the schematic. Anything else worth mentioning on here? Not really. Just it's good to know that these are the LED connections, and these two are the solar panel connections, and these two are the battery connections. It's worth mentioning that because these little modules are great for just repairing an existing solar light you've got that may have failed. The circuit boards often corrode in them, and it's just nice to, if you've got a favourite light, just to reincarnate it. Here is the schematic. I shall zoom down on the schematic. Nothing new to regulars to the channel because I have featured solar lights fairly frequently in the past. But I'll go over it anyway because it's useful to people who haven't seen this circuit before because it's quite a useful circuit. And cheapest chips. The YX801A is doing all the work in here. So we've got the nickel metal hydride cell with its improvised switch there. Usually with switches, I just say bypass them completely in these. They're always problematic. And then we've got the 4-panel solar panel here. And that creates up to 2 volts. That's needed because there is a voltage drop of a diode across here in the charging circuitry. And this is also used to monitor for dusk. So this generates the voltage. There is effectively a diode inside that diverts the current generated by the solar power to charge the nickel metal hydride cell. Then, at dusk, when it sees the voltage in this drop, it starts pulsing this inductor. Now, this is where there's the difference between the basic white LED solar light and the coloured one. The coloured one has this diode and this capacitor. With the straightforward white one, it just goes straight from here down to the LED. That's all the circuitry, the inductor there, and the LED. What happens, though, is it starts pulsing this inductor. And because this, when it pulses it, this end is positive, and it's pulling this negative by switching it to the 0 volt rail. And that builds up a magnetic field in here. Now, normally, the voltage up here is just 1.2 to 1.5 volts, so it can't pass current through the LED. The LED requires more than that. But when it starts pulsing this inductor, it builds a magnetic field up, and then when it turns off, it collapses. This end goes positive, this end goes negative. It adds on to the nickel metal hydride cell voltage, and it goes through either straight through the LED or through this Schottky diode and charges up this capacitor and through the LED. And the reason for the capacitor is because the colour changing LEDs don't like being pulsed on and off. They'll just stick at their first colour, which is usually red, and they'll just stay there. By adding this little rectifier and a capacitor, it means that the LED voltage doesn't drop below the threshold at which it resets, and it manages to do its little colour sweep. So they're useful little circuit boards. Very classic little circuit board. I mean, it's mass-produced to death. Oh, blimey, look at that. I didn't realise it actually zoomed. You've just seen the huge clutter. That's embarrassing. This is a different camera. Did I mention that? Yes, I did. I'm just looking around and seeing what did I just reveal. I revealed clutter. That's what I revealed. Past projects, things and projects that haven't been featured yet. And projects I'm working on for my other job. But anyway, that's it. It's the Tesco lights. They'll work fine. Oh, incidentally, the other thing you can do to prolong these is you can get some, well, let me zoom down onto this. You can get some nail polish and put it onto these to actually cover all the connections and the chip. The other option, if you're very impatient, is to get the ultraviolet curing glue and make a big pool of it. You can actually create a sort of the meniscus effect of a droplet. It covers it. It's like those resin badges you get. And once you've covered it completely, just get your ultraviolet flashlight and just cure it instantly, and that should act as a barrier against water corroding anywhere that there's DC present in the circuit board, because DC in water causes corrosion. But that is it. They look sensible, normal little lights. Quite surprised at the little contact, the little tab approach for these, but it's just probably cheaper than using a switch, and the switches are also unreliable, but I get the feeling this is going to be unreliable too. But they're useful for the little modules. I mean, if you buy a pack of 5, you could use some as lights, but you could also just strip them from the modules. And that means you would have spares for repairing other lights. But there we go. The Tesco lights. They're not bad at all. They're okay little circuit boards.